Hello everyone, welcome to the channel. I hope everyone is doing good. So in today's video, we are going to discuss about the embedding, more into the embedding. So like in the previous video, we have discussed about how to embed the word, how to embed the sentence. So in this video, we are going to take one more step ahead in the form of embedding the full paragraph, full documents for online documents through the API. We'll look into the wiki page of few of the movies, and we'll uh, chunk the text into different formulas, different techniques to chunk the text, create a different section of the text, then create the embedding on that, and we'll store it in some database. So in this video, we are not going to use any database. In the next video, we'll use ChromaDB, but now we'll have that embedding saved as a data frame. And then like this is the pipeline in which we'll read the document, create the embedding, and put it into data frame. Then we'll run the user query. That user query will be again transformed into embedding. Embedding will be done on the user query, and that embedding will be matched to the embedding already created with the document. And with the similarity search, the more nearest distance one, or most probable output will be given as an output. So this is the use case which is actually being done in most of the companies, in the form of semantic search. Like for example, there is a banking client or insurance client, and there are multiple internal documents. So the internal employee has to go through multiple documents to search for the some policy number, for some knowledge base. So in that case, with the help of AI, what the company is doing, they are creating a use case in which they are reading all the documents, creating the embedding on that, and storing it into some ChromaDB or any such kind of database where the vector embedding can be stored and can be visualized through a multidimensional form. And they run a user query, and the user query again embedded, and that is being searched with the help of similarity search or any other kind of algorithm. That search is done on the embedding which is already been done of the knowledge base. And this is how the multiple use case is run. So in our example, we will be reading the wiki page. So in your case, you can read any of the documents and do the same thing. And friend, if you have not subscribed to my channel, please subscribe to our channel. And if this video is relevant to you, and if it is making some contribution in your knowledge base, then please like the video and share this video to your colleague, to your friends. So we'll proceed with the practical code, like how this embedding will be done. So this is our Python code, for which we'll do all the embedding and all that stuff which we've discussed in the introduction in this video. So first we have to install few libraries. So we are going to read it from the Wikipedia pages. So this is the Wikipedia page for one of the movie, Kantara movie. So you can see there are multiple sections, multiple subsections, and this is the title itself. So we'll read this as a document and create the embedding of it. So what I'm going to do is, first I'm going to install the Wikipedia API libraries, and this will be installed in few seconds. Then this was already done, and then we have to import few libraries like NumPy, Pandas, and Wikipedia API. So this was also done. So now we are going to first look into how to read the data from with this API, and how to create the embedding out of it. So just ignore this title. This will be done in later part of this. So for making us familiar with the Wikipedia API and how we do the embedding, we will see here. So I have created a what I call title, like my the as a what I call title of this particular project is like Semantic Search Santos. You can give any name here. So we are going to use the Wikipedia API libraries dot Wikipedia. We have to give two parameter. One is which language we want it, and what is the user agent, like what is the title of this project. So that title of this project is Semantic Search Santos. So I'll run this. Then again, we have to tell the Wikipedia object, like Wikipedia underscore obj, which we have created, that which page you want to read. So I want to read a page called India. So if in Wikipedia, if I write it here India, so I'll get the detail of our country. So I'm writing it here India, the page. So this will read the page. So what is inside the page, if you want to see, like after reading the Wikipedia page for India, what is inside this India page? So you have to run this and you will get the full document. If you extend this, so you will see the whole document which is being published here, right? So what I'm going to do, I'm just ignore this one. And then now if you want to see all the sections, what all sections are there, the section is history, and then in the history there is a subsection, there is no subsection. Then we have a geography. So similarly, what all section and subsections are there, that has been displayed. So when you go here, you will see that what all things are there as a section here. Okay, so for example, entomology, history, these are the sections. Okay, now we'll okay, now we understood like how to read the file from Wikipedia, and then how to look into the sections, look into the text of that Wikipedia page. Now what we are going to do, we are going to apply the fixed size chunking. So in our example, what we are going to do, we are going to read three movie Wikipedia page. The first is Divana of 1992 movie of Sarukh Khan, and we have Three Idiots, another popular movie, and then Kantara, which was recently like the first version of the Kantara in 2022. So all these three famous movie, we are going to read the Wikipedia page. So we'll read the these three as a title. So I have stored it here as a title. We'll discuss this above code. First, we'll go one by one with how this function works. So I have defined this three movie name here, and we'll iterate through these page titles, and with each iteration, we are going to create a data frame and we are going to append it. Plus, we are also going to look into the chunking of it. So when you see this df is equal to process under page, so this is a function. When you go here, you will see that we have created a function process underscore page. So what it does, it read the Wikipedia page, like each page. The first page is the Divana movie, so the page title and Divana movie will come. So that page is being read here, then that is converted into like the text, and then I'm creating a chunking size of 1,000 word, like as per your need. Like this is just for an example, I have done 1,000 word. So we have to make sure that your word doesn't get or your particular word doesn't get cut. For example, there is a word called divana, so then it should be DEEWAN divana. It should not get cut from the middle or somewhere from this section. So for our example, we have taken an example of chunk size of 1,000 words. Then we are splitting the text with this chunk size. Okay, creating a data frame with two column. The first is title. The title itself is the name of the movie, and the chunk text means the chunking of the text which we have created. Okay, and we'll just append these all the iteration of the things into here. Now, see, I have also created another function called split text into chunks. So if you see, I'm going to split this text into chunks. So I'm giving the chunk size and the page text which we have read for each of the movie. So this is passed to this function, and here what it is done, it is now checking, like this function is checking that if is your word size, means combining concatenating each word of a particular Wikipedia page, if the word size is less than equal to the chunk size. So chunk size is 1,000 which we have defined, and each word size, appending each word and counting the size of that particular chunk, if it is 1,000, then it will append that word. Okay, it will have that as a chunk text. Okay, if it is not less than equal to chunk size, then it is going to again join the another word. So this whole purpose of this function is to create the chunk of the 1,000. This is defining the chunk size and passing it into the function. Overall, I am reading each movie, creating a chunk size of 1,000. Okay, so if I run this, so this already have run it. So if I run it again, so I'll just in a more readable format. So you will see that each of this is of 1,000 size, and you can see like this Divana movie one first 1,000 size, then another 1,000 size. So this is called the fixed size chunking, because we have defined the fixed size, and on that fixed size we are doing the chunking. Chunking means creating a particular bunch of the word from this whole document. Okay, so this is one way of doing the chunking. Now we'll move into the another way. So another way of chunking is based on the paragraph. So in the Wikipedia, we have multiple paragraphs, like photos, galleries, references. So if you move here, you can see there are multiple references, external links. There are multiple paragraphs which are not very important from our point of view. For a reader, it is important when you go through a Wikipedia page. But for an embedding point of view, that may not be so relevant. So we have created some of the redundant section here. So these sections are like, if you Google, you will get these are the redundant sections generally people use in this kind of use cases. And this section we will use in our algorithm, in our code, and will make it understand that if this section is there, then ignore that. And apart from this section, you can take another section, other section as a paragraph, and you can work on that. So what we are going to do, again the same thing. We are passing this files, this movie's name, and in this time we are having the title means the movie name itself, and the paragraph name also. And for each paragraph we are going to create the chunks. We are not, this time we are not having any definite size of the chunk. We are having the size or the limitation of the chunk on the basis of the paragraph. So you can just pause this video here and go through the code. So we are again extracting on the base of the paragraph. For example, for title in page titles, for each title, what we are going to do, we are going to extract paragraph, and here is the function of extract paragraph. So the text dot extend, and here we are getting each paragraph name. And you can see here extract Wikipedia page, then we are getting into the summary, extract paragraph from the section. And if it is like that section dot title, like particular paragraph which we have extracted, if it is not in the redundant section, this section, then it will go and read it, and it will append it. And finally we'll have a data frame in which we'll have the titles and the chunk text. So in this case, in this particular case, the chunk text will be the paragraph itself. It will be not basis on the 1,000 words like a fixed size. So we have already run this, and then you can see that this, like for example Divana movie, we have one paragraph. See, the sizes are very different. So this is one of the paragraph. Okay, so like for 3 idiots, this is another paragraph, this is another paragraph. So this is called the paragraph ways of doing the chunking. So in your document, this was the Wikipedia page, so we have written a code in this way. But if you have a multiple documents which you are reading, then you can go through this document and define the paragraph or define the section on that, on the document basis. Or the document, if document contains that way in the PDF format, that also you can read and create a different chunks. So we are not creating any embedding till now. We are just creating the chunks of the particular titles. And when we have all the chunks of the title, then we will create an embedding of it. Okay. So we'll go into another method of doing the chunking. So we have seen the fixed size method, we have seen the paragraph method, and now we'll go and see the section method. So for example, I'll write it here, Three Idiots movie. So, for example, there is a plot. There are like this will be considered as a full section, and then if, like for example, production, we will call it a one section, and inside the production we have a subsection called development. So now we have to look into if there is a subsection inside a section, then we have to read it. Like for in a production, we have a development, casting, filming as a subsection, and depending on that basis, we are going to create the chunk. So now we'll look into the chunking by section. So in this, we are going to look into the sections and the subsection as we have discussed. So apart from this, we have to add one more thing as a summary. Like the first section, we don't have any name for this section, but this is called as a summary. So I have added here as a page dot summary. When you read the page, and there is a summary. So what we are again going to pass this three movie name. So in this case, we are having a title, section titles, and also the section text in that title. So we'll have three column here: titles, what is the section name, and then the chunk text. Okay. So when you run this, you will get this kind of data. You will get the title name, all the section title, and the name of the what is the text, chunking text in that. So you can see like third one, and so production, and then music release. If you go into this production, you have development, casting, music release. So you will Okay. So this one I was talking about the development. So if you see here, production, inside that there is a development as a subsection. So it is considered the development as a subsection, casting as a subsection into that. Okay, so we have gone through three kind of chunking. The first is the fixed size, the second is the paragraph, and third is the section. So the you can use any of the chunking as per your document requirement. So in the Wikipedia, it was divided into these ways. So we have done in this way. So similarly, you can use for this other document. So this is the fixed size data frame chunking. We have this text. Then we have a paragraph chunking, which we have done, and then we have a section chunking. So you can store all this data frame into in your Google Drive for a later any later use cases. So we are not storing it anywhere. So but in the next video we'll store this in our Chroma TV, and from there we'll do the semantic search. As of now, we'll keep it as a independent data frame, and then we'll do the semantics on this. Now we have to create the embedding of all these three data frames, all these three types of chunkings data we have, and then now we have to create the embedding of it. So we have already created an embedding in our previous video, so we'll do it the same way. So we are going to install the sentence transformer. So I've already done it right now. So you can install the sentence transformer library, and then from this you have to import sentence transformer and the utils. Later we'll see what the purpose of the util here. We'll be using the same model here, mini lm L6v2, which you have done earlier. So I have already downloaded it. I will just run it if it is. Let me see. So now I will load this model. Uh, like if you don't know how to load the model, from where I have got this name, how to work on this model. So this has been discussed in the previous video. You can go to the Gen AI playlist and just go to the previous video of this. You will get all the details. I'll again load this pre-trained sentence transformer model. This is from the Hugging Face. You can go to the Hugging Face website. You will get all this model. Then now I'm going to create a generate embedding for the text. So this is generally done for like for the when we have to write the query. For example, I'll just show you here. I have used user query. So when you will write the user query, and that query will be also converted into embedding for the doing the semantic search, similarity search. So this function is created for the same thing. Okay, for a particular query to be done. So this is a data frame where we are creating a embedding for this chunk. We'll see how we are doing it. So now you see we have all these three data frame from the fixed chunk, paragraph chunk, section chunk. We are passing it into and generate embedding on underscore df, and this data frame is passed into it, and one particular new column will be created as an embedding column, and that column will have all the embedding of that particular row chunk. In the each row we have a chunk of text. So we'll create the embedding of it one by one for each of the data frame. So I'll pause the video, and I'll just create it. Okay, it's done now. I'm not going to pause it. I think it will be done immediately. All the three chunkings has been done. So we can see the fixed chunk df. So one more column will be added, the embedding column. Okay, so this is for the chunk text, this one. And then now we'll go for the paragraph chunk df, and this is for the section. So for each of the data frame we have each column. So in section we'll have one more column as a section title, because this was before embedding itself we have generated the section title. So we can see a particular a single row of like for a fixed chunk, what is the a single row of this vector or this tensor vector. You can see it, like we will come to know what all vector distance is there, and how this has worked. So if you want to know more about what is this tensor vector, why we create it, how it is created, you can go through my previous video. We have discussed that in detail. So now we have all the chunk text, we have the embedding of each chunk. Now we are going to build the semantic search, like as I have mentioned that I'll fire one query. So now we have read this document, created the embedding, stored into database. So in our case we have in a data frame now. So we have done this part. Okay, this part is now done. So now what we have to do, we have to write the query, create the embedding of it, and do the similarity search, right? So we'll go into it now. So this is for getting the user input. So I'll just write an input, for example, in which movie Shahrukh Khan has acted, has worked. Okay. Okay. So now this has been passed into this user query. So I'll define a function to create a similarity algorithm, like with the help of, as I mentioned, that we have read the utils. We have read utils while reading the libraries above. You can go just do the backward of this video. You can look into it, and then with the help of PyTorch, we are creating the similarity vector. That similarity is generally the nearest distance of that particular word, and that similarity is being returned. So what we are going to do, we are going to pass the user defined query, then the df itself, then the embedder. Okay. So in this function, we have to perform the semantic search and return the result. So it starts from here. So what we'll do, we'll fix chunk result. So what we are going to do, doing the semantic search. Okay, in the semantic search, I'm passing the user query. I'm passing the fixed chunk, like this is for the fixed chunk, this is for the paragraph chunk, this is for the section chunk, and what is the embedder. Okay, so now this I'm passing it here. So semantic search function is called. We are passing the user query, df, and embedder itself. And you can see the we are creating the query embedding with this. Okay, user query, and the user query embedding is created into the query embedding. We are putting one more column, which is similarity, and this is done here. Calculate, we are calculating similarity for each of the chunks. So here you can see calculate similarity on basis of the query embedding which we have created. Sort it on the basis of like which is most similar will be put it at the first rank, and top three rank has been defined. There will be multiple ranks, so we are getting the top three rank. So I'll run this function and this function, and then perform this. Okay, now we'll see the result, like what is the result like for the fixed chunk, for paragraph chunk, and for the section chunk. Okay, so because we have done the top three, so we are getting top three. 0.52 means 52% similarity is there. So thought of many actor playing the lead role. Uh, so my question was different. Shahrukh Khan as a Raja Sahai. You can just click on this. You can get it from here. Like I've looked in which movie Shahrukh Khan has acted. So it has written Divana, and then again Divana, top two, top three. Why Kantara is there? Maybe some similar name will be here mentioned here. Similarly, you can see 3 this is not giving the good result, the chunk size. Paragraph chunk is giving more realistic result. Similarly, for the section also, you are getting the good result. Like Divana is the correct answer for that. Okay. So this way you can have multiple uh, kind of queries, like I'll write it the query here as one more query I want to write. Uh, Mm, Give me summary of Three Idiots movie. Okay. So now I'm going to run this again. Okay. So you can see the Three Idiots movie summary is created in three ways, which is more, say, 72% relevant. So similarly for the paragraph also you can see it here. So you can play around, you can see which way is very much relevant to you, very much close to your query. You can give the query and you can search on that. So what we have done, we have read the document, we have created the embedding, stored the embedding, then we have fired one query. That query embedding is created, and that embedding is being done the similarity search or similarity vector has been created. That number has been similar number has been created with all the embedded chunks, and then the more relevant output is given to you. Okay, this is how actually it works. You can also create a graph on top of it that depends on your use case. So for creating the similarity graph or multidimensional vector graph, you can look into my previous video. It has been discussed in more details. I hope you will understand all this concept. The coding may change because we are doing the coding by reading through the wiki page, so it's different. In your case, it may be more complicated or more simplified. You can pause the video and look into the code and all. If you have any doubt in this process, any conceptual doubt in this process, you can put your doubt in the comment. I'll just come up with an answer. Till then, happy learning and go through all this algorithm, go through all this videos, and you will get to know more about the embedding, more about the semantic search. So I keep on saying that Gen AI, the bubble of Gen AI may burst, or what people is saying that Gen AI is not going to give a good result on a financial ways. But there are few things in a Gen AI development which will stay for long, and the semantic search is the one thing which is going to stay for a very long period of time. Okay, thank you and happy learning.